Ideal gas law. So there's three fundamental gas laws that discover the relationship of pressure, temperature, volume, and amount of gas. These laws are Boyle's laws, Charles' laws, and Avogadro's laws. Boyle's laws tells us that the volume of gas increases as pressure decreases. Charles' law tells us that the volume of gas increases as temperature increases. And Avogadro's law tells us that the volume of gas increases as the amount of gas increases. But the ideal gas law is a combination of all three of these laws. So this is the ideal gas law. It's PV equals nRT, and R is a gas constant, so it's always going to be 0.0821. N is going to be the number of moles, P is pressure, and V is volume. And this is another way that it's commonly written. Like if you need to find the volume, then this is how the equation will be written. So this is a simple example. So what is the volume of 2 moles of gas at 57 degrees Celsius and 5.5 atmospheres? So we start with the normal ideal gas law, which is PV equals nRT. And we're trying to find the volume, so we're going to rearrange the equation. So now we have volume by itself because we divided both sides by P. And before we plug our numbers in to the equation, the temperature always has to be in Kelvin, and right now it's in Celsius. So to get to Kelvin, you always just add 273 to the Celsius number. So you're going to add 57 degrees Celsius to 273 degrees Kelvin, and you're going to get 330 degrees. So now that we have our temperature in the right Kelvin, we can plug our numbers into the equation, and you have 2 moles times 0.0821, which is our gas constant, times our temperature, which is 330. And then you're going to divide that whole number by 5.5 atmospheres, and you're going to get 9.825 liters. Volume is always in liters, but everything else is going to cancel out. So this atmosphere cancels with this one, this mole cancels with this one, and this Kelvin cancels with this one and leaves us just this liter. This is combined gas law right here, and this is just a picture of the different people that helped, whose theories helped create the ideal gas law. So this is another example problem that's a little bit more complex than the last one that we did. So if we have 2.25 liters of a gas at 16 degrees Celsius and 1 atmosphere is compressed at a pressure of 125 atmospheres at 20 degrees Celsius, calculate the new volume of the gas. So here we're going to use these equations. So we have our initial pressure, which is 1 atmosphere. We have our final pressure, which is 125 atmospheres. Our initial volume is 2.25 liters, and we're trying to find our final volume. The initial temperature is 16 degrees Celsius, and we're just going to add that to 273 to get 289 degrees Kelvin. And then our final temperature is 20 degrees Celsius, and we're going to add that to 273 and get 293. And when we rearrange our equation, it's going to look like this. N is a constant, so we can take that out. So we're just going to have P1, V1, T1 over P2, T2. So when we do that, we have 1 atmosphere times 2.25 liters times 2 93 degrees Kelvin. We're going to multiply all that together. And then we're going to divide it by the product of 125 atmospheres and 289 degrees Kelvin. And we're going to get 0.0182 liters. This is the final answer. This is the final volume. And like I said in the last problem, all these units are going to cancel out with each other, and you're going to be left with liters.